Today we're going to do the law of sines, which is similar to the law of cosines, but a completely different formula, so I guess not that similar. Again, we want to maintain that relationship. Capital A is across from lowercase a, capital B across from lowercase b, and so on. Doesn't matter what letters you use. You could use X, Y, and Z. We like A, B, and C, though, because generally it's kind of easier to tell if it's capitalized or lowercase. It doesn't really matter. I like to put the angle on top. You can put the angle on top or the side length on top. I'm going to write this as the angle. So you do the sine of angle A, and that goes on top of side length A. And then we just proceed on down the line. We can do angle B, sine of angle B over side B, and the sine of angle C over side C. Now, solving a proportion with three things is not really something you might not want to do, but like, for example, you just pick any two. I guess I was going to erase it, but that seems dumb to erase it. So you just pick any two, and then you can cross multiply. It's very easy to do, much easier than the law of cosines to put in the calculator. Now we have some other tricks when it comes to this, and we'll get to those in a minute. I like to establish the relationship that I have. For example, what I mean by that is I have this angle and this side is directly across from it. That's what I have. So I know that I have the sine of 47 over 15. Now, what do I need? Well, I have to use x. And across from x is 104. So then the sine of 104 goes in the numerator. Start in the diagonal of the two things that you know. Remember, the sine and the 104 are stuck together. So in the calculator, you're going to enter 15 times sine of 104. You can, and of course, they give you parentheses. If you want to keep going, you got to close the parentheses, and you hit divided by sine of 47. If you don't want to keep going, then you don't have to close the parentheses right here, and you can just hit enter and then hit divide by sine of 47. But this is one step. And all of this is one step in the calculator, and you just get the answer. Because the answer is a side length, so it comes out exactly what you want. We're going to 1/10. We'll call this 19.9. And this, of course, has units. So you might want to double check on your calculator, making sure you're doing that okay. Now for this triangle, when I go to establish what I have, I can see that I'm missing that angle. So you're going to remember there's 180 degrees in every triangle. So you do 180 minus 42 minus 63, and that gives you the 75-degree angle right here. So that's a 75-degree angle. So now we can set it up. Sine of 75 over 28 equals, I need to have the x there, and that's the side length, and across from the x is the sine of 42. So again, start on the diagonal of the two things that you know. So you're going to do 28 times the sine of 42, close the parentheses, divided by sine of 75. Of course, you have to make sure that you're in degrees. So make sure your mode is the degree mode. We do these in degrees, just like the law of cosines. And so we get x equals 19.4 feet. So when you're looking for a side length, generally it goes very, very well. Very smooth, no tricks. The problem is when you're looking for an angle. If you're looking for an angle and you are starting with angle side side, now they have it nicely written here as side side angle. Angles side side means we know one angle, and then just any two sides. Doesn't really matter after that which two sides we know. But the problem is that the angle is not in between, so that the angle is not actually the one that's sandwiched in between those two sides. It's just some other angle. In geometry, you were told that angle side side is not something you can use, and that is because it creates more than one triangle potentially. So you could have one triangle, and it says that right here. You could have one triangle, two triangles, or no triangles at all. So this is why you stay away from it in geometry. You might have thought it's because of what it spells, but it's really because it just doesn't work. But we're going to use it now. So some things that you got to remember. when you're using sine, you can only have numbers between -1 and 1. Excuse me. This matters because on the calculator, if you have an angle that isn't going to give you anything, then you know it's maybe you have an arithmetic error or there's something else wrong with it. So you got to be careful with that. So that's something I look in the calculator for. Now, positive sign is in quadrants 1 or 2. So that means the classic example is, right, the sine of 30 is 1/2, and the sine of 150 is also 1/2. So two angles have the exact same answer. So that's the problem. Which one do you want? Maybe you want them both. So that's the issue. Now yours are going to subtract from 180. That's how we find what's missing. So to find the other possible angle, this is the trick right here. This is important. And in 5 minutes, you're going to be like, why did she subtract it from 180? It's because of this right here. To find the other angles that are choices. The sum of the measure of any triangle, of course, you always get 180 degrees in your triangle. And no triangle can have two obtuse angles. So it is a kind of a combination of all these little facts that we're going to use here. So if you notice the directions say, give all possibilities. I'm trying to still keep my blue arrow here and keep all the rest of this. So you're going to have some that have two angle answers or two triangle answers, and some that have one, some that have none. So when we go to draw this, okay, every triangle, every one of these down here is triangle ABC. You can draw it any way you want to. So you draw a triangle, it doesn't matter what you call angle A, angle B, angle C. I'm just trying to keep all this stuff together here. So just draw it. A, B, C. Again, it doesn't matter. Angle C is 89. I like to have a picture because I like that across the triangle stuff. AC is 34. AB is 26. And we're looking for the measure of angle B, which I am going to continue to just call angle B because I think that's easier than switching it to a variable. So we're going to go for it. We're just going to use the law of sines. So we know that this is our major relationship. So the sine of 89 over 26 is equal to, well, we don't know, sine of angle B over 34. So this is our other relationship. There's our variable. Our variable is now the angle. So when you're missing an angle, you remember you have to do the inverse function. You still start on the diagonal where you know two things. So we're going to type into the calculator 34 times the sine of 89, close the parentheses, divided by 26. And when you do that, you get a decimal. So then you have to go second sine, the sine key, go back to second, and go down to the key that's the negative sign. It has ANS above it. And what that does is it inserts that last decimal, so you don't have to copy it down, you don't have to remember it, you don't have to round it, you don't anything. And then just hit enter. And you get that it doesn't give you an angle because it's too big. So we're going back to this. This takes you back up to here, right? The sign has to be between -1 and 1. And if it's not, there is no solution here. So we're done. We don't get a triangle. The information that was given does not create a triangle. It can happen. It just did. All right, so for number 4, we're back to triangle ABC. Again, I'm gonna just label my triangle different just to show you that it just doesn't matter. So angle B is 95 degrees, AC is 34, and BC is 21. We're looking for the measure of angle A. So again, here's the relationship that we have. So the sine of 95 over 34 equals, well, we don't know angle A, so sine of angle A over 21. And again, we start multiplying. So it is on the diagonal that you know. Mine have a tendency to be the kind of the same diagonal because I set the problems up the same. So 21 times the sine of 95. And then we're going to do, close those parentheses there, divided by 34. And then you have to do second sine, second answer, right? So second sine, second answer. And we actually get an answer. So we get that angle A is, we're looking for angle A, is 38 degrees. Now, or going back up here to my blue arrow, to find the other possible angle, subtract 180. So now we have to do 180 minus 38. And basically, you just have to figure out, does this make a triangle? There's 180 degrees in every triangle. Does it work? So we know that angle B is 95. You can't change that. So angle B is 95 over here. Oops, I don't know what I'm trying to write. I lost track of myself. So this is supposed to say, sorry, angle B equals 95. Well, already over here, we've got too much. This doesn't make a triangle. So this is out. And so then now we need to figure out what angle C is. 180 degrees in your triangle. Angle C is 47 degrees. So find all three angles. And so now we know that this is what our triangle is. It only makes one triangle. You don't have to say one triangle. You have to give the answers. Now for this last one. Space might be an issue, but again, I'm going to label this even more differently again. A, B, C. There. I have three different triangle ABCs. They're all pretty much exactly the same. So angle C is 30 degrees. AC is 29. AB is 28. We're looking for the measure of angle B. So again, here's the relationship we know. Sine of 30 over 28 is equal to the sine of angle B. I'm going to use a capital B over 29. Multiply that out, and you get that angle B is equal to 31.1 degrees. Or, now you do the 180. Do 180 minus angle B, or angle B could also be 148.8 degrees. We could have two triangles here. Now we know that angle C is 30. And then you have to figure out, do you have enough to make angle A? Here we do. So here angle A would be 118.8. So there's one triangle. And here we actually do as well. So 180 minus all these numbers that we know, it's very small, but it is enough to make an angle. So this is what two triangles look like. So you generate that from the answer that you get from the calculator. The one you calculate, you subtract it from 180. And then either it works like this one, or it doesn't work like this one. Or if the calculator says, hey, you don't even get an angle, then you're done. There isn't two triangles, there's no triangle. So try the problems on the back, and we'll go over this in class.